Given the function f of x is equal to 10 minus 16 over x, find all of the points in the interval from negative 2 to 8 that satisfy the mean value theorem. Let's just blindly march forth trying to answer this question without thinking too much about what the mean value theorem states. Basically, the mean value theorem says that the slope of the secant line is equal to the slope of the tangent line at some point in the interval. So what is the slope of the secant line? From x equals negative 2 to x equals 8. Well, it's equal to f of 8 minus f of negative 2 over 8 minus negative 2. F of 8, if you plug an 8 into the original function for x, you get 10 minus 2, which is 8. And if you plug a negative 2 in, you get 10 plus 8, which is 18. On the bottom, we have an 8 plus 2. This comes out to be negative 10 over 10, or negative 1. So the mean value theorem would say that there must be some point in the interval from negative 2 to 8 where the derivative, or the slope of the tangent line, is equal to negative 1. So we need to find the derivative of this function. The derivative is, well, let's first rewrite f of x without the fraction. 10 minus 16x to the negative 1. So now f prime of x is equal to 16x to the negative 2, or 16 over x squared. So we are looking for a point where 16 over x squared is equal to negative 1. Is that possible? Impossible. Why is that impossible? That's impossible because the square is always positive. So there's no way that 16 over x squared could be equal to negative 1. So what's going on here? What's going on here is that we just did way too much work, because if we look back at the original problem, let's move all of this down. We really need to first ask ourselves the question, does the mean value theorem even apply here? Well, what are the conditions of the mean value theorem? The main condition is that we need to have a function that is continuous on the closed interval and differentiable, at least on the open interval from negative 2 to 8. The problem is that this function is not continuous, on the closed interval, because there's a problem where? There's a problem at the point, look where the x is, there's an x in the denominator, discontinuous at x equals 0. This is discontinuous at x equals 0. There's a vertical asymptote at x equals 0. So the answer to this question is can't be done because the mean value theorem does not apply.